Okay, let's check out some examples. So we are going to find the radius and the interval of convergence. I'm going to just abbreviate interval of convergence as IOC. It is interval of convergence from here on out just because I'm too lazy to write it out. That's honestly what's going down. So here is my series. I'm going to go from 0 to infinity. And I have x to the k over k factorial. And a is equal to 0 for this. All right? So this is what I'm getting. I'm going to find the interval and the radius of convergence for each one of these. Okay, let's do this thing. So I know the center, well, shoot, I shouldn't have put this down yet. You just know it because you look at it and you can see that. What is my A? Now that we've already put it down there, let's ask the question, right? So check this out. I know that my actual formula here is C sub k x minus a here, right? From 0 to infinity, I should write that. Look at what's happening for this one. X and x, right? Does this x have anything here with it? No, and that is how I know, oops, let's go blue, that a is equal to 0 because there's nothing there next to my x. Okay, so it's good to know that my a is equal to 0 here. I want to know what I'm centered around. That is helpful. Whenever I'm trying to figure out what my interval is, it's my radius is around that interval. All right, so when I have this kind of problem, we are then going to use either the ratio test or the root test when we do these. And look at this, I have a factorial. So as soon as you see that factorial, what is your big tip off for any kind of series ever? Ratio test, I know. And the whole deal here with all of this, with this factorial, and that's what our formula is for those Taylor too, right? Okay, so let's use it then. I'm going to be looking at my ratio test. So the ratio test me that there's that some value that my limit as k approaches infinity here of x to the k plus 1 over k plus 1 factorial divided by my original here, which will be k factorial over x to the k. And then we clean it up. So simplify this. The limit as k approaches infinity of x to the k times x, right? Because you split this up. This is x to the k and then this is x. Like bases, add the exponents. I have that k plus 1 times k factorial. And then here I am simplifying. X to the k cancels, k factorial cancels. And then I'm taking this limit. So if I'm taking the limit, I'm going to scoot this up a little bit. As k approaches infinity, I have the absolute value here of x over this k plus 1. Now so the only thing that I'm looking at here, so x is just the variable. K is what I'm taking the limit of. So what happens whenever I'm looking at this? I don't know why I did that. It's the absolute value of this whole thing. So the absolute value. I don't know what's wrong with me. All right, so here I'm looking at this, but I'm only taking the limit here of k. What does this go to? 0. Now think back, what are your rules for your ratio test? I know that I have some value. I'm associating that with 1. So if this is less than 1, that means it converges. Good. And it converges in this instance, because it's this absolute value, it converges absolutely. So if I'm looking at my graph here, I'm centering around 0 because that's my a value, right? A is equal to 0. So I'm centering around 0, and this converges absolutely, meaning it converges everywhere. Okay, therefore, just like anything else that we're doing, the series converges absolutely The radius of convergence is infinity because that's what we're actually asked to find up here, right? The radius in the interval of convergence. And the interval of convergence is also infinite. All right, so you're finding your radius of convergence and your interval of convergence. And this one converges absolutely. If we were to do the ratio test at last chapter, we would have determined that it converges absolutely also, right? Okay, let's do another one. Here's example 1b. Find the radius and the interval of convergence, okay, of this one. I'm going from 0 to infinity of -1 to the k x minus 2 to the k all over 4 to the k. What is my center? 2. Good. How'd you get that? Yup. This is x minus a, right? That's part of my pattern, and that's how I can come up with my center. Good. Okay, now, what test are we going to be using here? Yeah, we're using the root test. All of these are to some exponent. So yes, we are definitely using the root test. Good. Let's do it right now. If I'm using this root test, I'm taking the limit as k approaches infinity here of the absolute value of this to the 1 over k. When I'm going back through this, you multiply times every single exponent. When you multiply by all of those, the variables in the exponent cancel out. And I am now just taking the limit as k approaches infinity. This is absolute value. So the absolute value of -1 is just 1. The absolute value of 4 is 4. So I have the absolute value of x minus 2 over 4. Do I have any k's left in this problem? No. So my limit as k approaches infinity is the absolute value of x minus 2 over 4. Now here's the deal. I am taking the root test. My goal is to find out where this converges. So what criteria is going to make this converge? Yes, where this is less than 1. This is the criteria for the root test to converge. Right? My value has to be less than 1. So that's the criteria for my root test. Okay. So if this is my criteria, I now have to figure out what values of x. I'm going to scoot this up. What values of x are going to throw down here. So I have the absolute value of x minus 2 divided by 4 is less than 1. I'm going to multiply both sides by 4. The absolute value of x minus 2 is now less than 4. This, let's go black, is R. Do you remember? So now I'm going to let's send it back here real quick. X minus a is less than r, and that's how we get that r. Remember that? Criterion number 2. All right, so here is x minus a, which we know our a is 2, is less than r. So I know 4 here is now r. Okay, now we try to figure out what my interval is. So anytime you have this absolute value, then you can solve your absolute value. So -4 is less than x minus 2, which is less than 4. Add 2 everywhere. -2 is less than x, which is less than 6. This is my possible interval of convergence. So here, I'm going to go from -2 to 6. I know my a value here is 2, And then I know this interval is going to be plus 4. This interval is minus 4. Do you see that? So I know my radius is 4. Now the real question on this is what is happening at the end points? So you have to check the end points. In the original series. Because you have to say, does the endpoint count or not? Am I using parentheses or brackets? And let me tell you, you can have anything possible. They can both be parentheses. I can have a bracket with a parenthesis. I can have two brackets. You have to check it. There's no other way to determine that. You just have to check it. So using my original series, we're going to now go through here and check these endpoints. So I'm going to check when x is equal to a -2. So plug that in. I have my series from 0 to infinity of -1 to the k, -2 minus 2 to the k, all over 4 to the k. Scoot this up. So I'm saying what value of x is going to work. So you plug in that value of x. So do a little algebra. I've got -1 to the k and -4 to the k over 4 to the k. This negative sign right here you can pull out separately. So I'm going from 0 to infinity of -1 to the k, -1 to the k, 4 to the k over 4 to the k. And then I see these 4 to the k's cancel. These are like bases. If I have like bases, you can add those exponents. I have -1 to the 2k. What happens when you have that even exponent? Right? No matter what, my even exponent, when I take this limit, what will always happen? Yep, the limit as k approaches infinity of -1 to the 2k will always equal 1 no matter what. Which does not equal 0, and which test did we just use? Yes, we did. So this diverges by the divergence test. So that tells me at -2, this is going to be a parenthesis. All right? So -2 I know is a parenthesis because it diverges. All right, let's try on 6. I'm going to use a different color so that they don't blend together. So x is equal to 6. K is going from 0 to infinity, -1 to the k of 6 minus 2 to the k over 4 to the k. This is now 0 to infinity of -1 to the k, 4 to the k over 4 to the k, and there they go. Whoop, whoop. Now I have the series of -1 to the k. Well, what happens when we take that limit? The limit as k approaches infinity of -1 to the k is going to either be +1 or -1. Are either one of those equal to 0? No. So again, this diverges by that divergence test. All right? So we're taking back to the tests that we learned before. We are still talking about series. We can determine convergence and divergence. We have a whole slew of tests, pardon me, to figure that out. So use that. But the fact that both of these diverge, my radius of convergence is equal to 4, and my interval of convergence is parenthesis -2 to 6. I'm going to scoot this in. My question way up here asked me to find my radius and my interval of convergence. We found our radius of convergence up here, but if you still have an x, you take this limit and you still have an x in there. You're going to have an interval and you have to check those endpoints. That's your tip. If you still have an x when you take that limit, then you're going to have to find your interval of convergence. And you have to test those endpoints to see if they work or not. So on my interval over here, I have parentheses in between that. Okay, good.